Selecting the sample for a research study. When you conduct a research about a group of people, it's rarely possible to collect data from every person in that group. Instead, you select the sample. The sample is the group of individuals who will actually participate in the research. To draw valid conclusions from your results, you have to carefully decide how you will select a sample that is representative of the group as a whole. So there are two types of sampling methods: probability and non-probability sampling. Probability involves random selection, allowing you to make strong statistical inference about the group. Non-probability sampling involves non-random selection based on convenience or other criteria, allowing you to easily collect data. So first, you need to understand the difference between a population and a sample. And identify the target population of your research. The population is the entire group that you want to draw conclusions about. The sample is the specific group of individuals that you will collect data from. The population can be defined in terms of geographical location, age, income, and many other characteristics. Probability sampling means that every member of the population has a chance of being selected. It's mainly used in quantitative research if you want to produce results that are representative of the whole population. Probability sampling techniques are the most valid choice. So there are four main types of probability sampling: simple random sample, systematic sample, stratified sample, cluster sample. Simple random sampling. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. To conduct this type of sampling, you can use tools like random number generators or other techniques that are based entirely on chance. So, for example, you want to select a simple random sample of 100 employees of company X. You assign a number to every employee in the company database from 1 to 1000 and use a random number generator to select 100 numbers. Systematic sampling. Systematic sampling is similar to simple random sampling, but it's usually slightly easier to conduct. Every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. For example, all employees of the company are listed in alphabetical order. From the first 10 numbers, you randomly select a starting point. Number 6. From number 6 onwards, every 10th person on the list is selected. And you end up with a sample of 100 people. Stratified sampling. A stratified sampling involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. To use this sampling method, you divide the population into subgroups based on the relevant characteristics like gender, age, income, job, etc. Based on the overall proportions of the population, you calculate how many people should be sampled from each subgroup. Then you random, so you should random or systematic use systematic sample to select a sample from each subgroup. So, for example, the company has 800 female employees and 200 male employees. You want to ensure that the sample reflects the gender balance of the company, so you sort the population into two strata based on gender. Then you use random sampling on each group, selecting 80 women and 20 men, which gives you a representative sample of 100 people. Cluster sampling. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample. Instead of sampling individuals from each subgroup, you randomly select entire subgroups. It's practically so if it's practically possible, you might include every individual from each sampled cluster. If the clusters themselves are large, you can also sample individuals from within each cluster using one of the techniques above. This is called multi-stage sampling. So this method is good for dealing with large and dispersed population, but there is more risk of error in the sample, as there could be a substantial difference between clusters. It's difficult to guarantee that the sampled clusters are really representative of the whole population. So, for example, the company has offices in 10 cities across the country. You don't have the capacity to travel to every office to collect data from, so you use random sampling to select 3 offices. These are your clusters. So in this video, we have analyzed probability sampling. We will continue about non-probability on the next video. Thank you for attention.